All right, it's nice to be able to be here today. We will be presenting the work, the project and paper that we've been working on together with Sander Siepel and Jan as well. The title of our work is the interplay between craving and impulse control and adaptive network model for drug addiction treatment. So we're going about addiction again, but in a slightly different way this time. So we'll just quickly walk you through the structure of this presentation. We'll start off with the background of addiction a bit, then just briefly look into the modeling approach that we used, which is also by adaptive temporal causal networks, then go over to the model that we kind of built in the framework of this concept based on addiction and treatment. Then we will go over to the validation of the model and simulations that we run, just to finish off with some concluding remarks and a takeaway. So first, a bit about the background of addiction. So addiction, which is like a chronic relapsing disorder that is characterized by compulsive drug seeking and intense cravings, is a disorder that is caused and maintained by a complex interplay of many factors. We listed just some of them over here. But the important thing to note here is that addiction is not only caused or facilitated by many different factors, but also by the interplay between these factors, creating a really complex picture about how an individual can come to start consuming drugs and later on then become addicted to a certain substance. And what is also important to note is that much research has been focused on how to treat addiction, and many treatments have also been proposed and are currently being used as well. Nevertheless, despite these efforts, a treatment that we could consider as highly effective in treating addiction has not really yet been found. And relapse rates remain very high. So therefore, we kind of recognize this complex picture in which addiction develops and is maintained, and also the need to further understand it to be able to effectively be able to treat this disorder. And therefore, the goal that we proposed ourselves for this project and for this study was to introduce an adaptive temporal causal network model that would allow to computationally simulate drug addiction and its treatment. So we use the similar framework that has already been mentioned, which is what I will just walk through very quickly. But we modeled based on adaptive temporal causal networks. Here's a very simple just representation of such a model, but basically we have states which are represented by nodes. These states have connections that can have different weights depending on how strongly one factor influences one state influences the other state. Speed factors indicate for every state how much that state changes in response to the incoming connections. And then a combination factor for every state also indicates how the single individual incoming connections impact that state together, then creating an aggregated impact for that state. So then these states have different values between 0 and 1 that change throughout time depending on the incoming connections and their initial values. Now, the simplified model that we see here is just a temporal causal network. But often the characteristics that such a model has also change throughout the time course of, for example, a simulation or the development of time. And that would mean that a model by itself can also be adaptive. Now, how do we incorporate this? We incorporate this by, we can't see this here in this simplification, but we incorporate this by adding self-model or verification states that then represent these characteristics and how they can change as well. So what did that look like for our model now in the case of drug addiction and its treatment? So what you can see here at the very right is the drug consumption that an individual would have. And the rationale that we had while building this model was closely linked to the definition of drug addiction that we had, which was mainly based on the idea, like I said already, but it's mainly that drug addiction is characterized by intense drug craving and the inability to control those impulses. So then we reasoned that whenever the ability to control an impulse is higher than the strength of the craving that a person has, a person will be able to withstand the impulse of consuming drugs and will not consume. If it is the other way around, craving is stronger than the impulse than the ability that one has to control one's impulses, a person will give in and will consume drugs. So that is why we have these other states here that are fundamental in determining whether the person will finally will in the end be consuming drugs or not. Now, these states by itself, we know that the picture of why someone would consume drugs or eventually become addicted as well is much more complex than that, which is why we have all these other states that have been frequently found in the literature and where there's like really a considerable body of research on, that then interact with impulse control and craving strength. It would probably be a bit too much to go through each of them and how they're connected and why. But it has, for example, been found very frequently that the more exposure to drugs or like the exposure to environmental cues remind a person of the drugs, which we can see here at the bottom, really impact how much a person craves the drugs. On the other hand, a person's social support and network really has a strong influence on a person's emotional well-being. And we know that whenever we're more stressed or more anxious, the person is also more likely to not be able to control their impulses as well, and could then, in the case of drug consumption, give in and consume. Now, with these three steps, so drug consumption, impulse control, craving strength, and then these other factors that in turn impact this, we had then built a picture of how a person or why a person would consume drugs. And then we needed in some way to build in treatment. And the way we went about this is we know that different treatments try to very specifically target specific aspects or factors that we know that are associated with drug consumption. So what we did here is then we had a state that represented treatment. Nope, that was the wrong direction. That represented treatment, and that then had outgoing connections to several of these factors that we know that are often impacted or targeted by treatment, and gave those outgoing connections different connection weights. For example, we know that contingency management is all about increasing an individual's motivation to abstain from drug consumption, because it consists in giving a person vouchers whenever they abstain from consuming that they can then exchange for other goods. Cognitive behavioral therapy would then be impacting coping mechanisms because they work on those and also on the beliefs that a person has about drugs. And for example, inpatient hospitalization really tries to tackle the issue of environmental cues and exposure to drugs, and therefore reducing craving strength. So what was important about this model is that we wanted to make it as flexible as possible to be able to represent as many different realities and treatments as possible. And that was there. With this model, we made this possible by being able to give all these different outgoing connections from treatment to these other factors different weights. So if we were looking at a treatment that was really focusing on coping mechanisms and, for example, environmental cues and exposure to drugs, we could give all of these outgoing connections a high value, let's say 0.9 or 0.8, whereas these would then put relatively low. But in addition to being able to model different treatments, we also know that addiction patterns vary across addictions, addictions to different substances, and as well individuals. For one person, cultural norms could be very important in determining a person's drug consumption, but for the other one, it's really the biological vulnerability that plays a key role. And therefore, we thought that this model could also really be very unique and useful in providing insight or being able to model individual cases or cases of specific drug consumption patterns, because it would allow to really give different values to all of these different factors depending on the context that I want to look at or study or understand further. So then, so this model is it's just a causal temporal network model with no adaptivity in it. But we know that when it comes to drug consumption and addiction, and especially its treatment, learning plays a very fundamental role. So we really wanted to bring that in as well into our model, and we did that by making connection weights as well as thresholds adaptive. By making connection weights adaptive, we also followed the principle of behavioral learning that has been mentioned a couple of times, which really builds on the fact that the more often I use a connection, the stronger it becomes, and also the other way around. If I don't lose a connection, it becomes weaker. So here we have several connections that can become stronger over time, but also thresholds. We argued that the more often a state would become active, like for example, motivation, the stronger it would become afterwards to activate that state as well. So yeah, it might be a bit too much to go into each of those and why each of them is connected. But with that, we really built our model that enabled learning as well as flexibility. And then we wanted to validate our model and see how it would behave if we were trying to run different scenarios or simulations. And what we did, so we wanted to compare to what we know from the literature. The issue with addiction and its treatment is that there is really not too much consistent and specific quantitative data that we could compare it to. However, what is known is that in general, there's like strong consistency instead showing that longer treatments are more effective and also more comprehensive treatments are more effective. So that is what we modeled then, and we wanted to see whether that would happen in our model as well. So then in the paper, we included four example scenarios. Two of them we have a comprehensive treatment where all the different states here have a like treatment has a connection to all different states. Whether then we have a less comprehensive treatment where drug beliefs and motivation, so these two we just chose them randomly, were not active. And then we also varied the length of the treatment to see also again how our model would behave in that scenario. So here we'll go into the first scenario that we run, a concept from comprehensive treatment. So all outgoing connections are active of long duration. I hope this is visible or it's not too small. But basically what I want you to first focus, so here we have the different models, so the different states and the values that they have across time units. And what we have here is I first want you to focus on the blue line that you can't really see at the beginning, but it goes down here and then it goes up here and then down again. Basically, this is our treatment. It's our treatment that starts at time point 100, then goes on for 100 more like time units before stopping again. And this is the value that all our states have before treatment starts. Now, what is interesting to note is that as soon as our treatment started, here in purple, we have craving strength, which if you remember is one of the two states that was just before drug consumption. So it was really about the interplay between craving strength and impulse control starts to go down as soon as our treatment starts. And then also our impulse control starts to first slowly, but then more and more gradually go up. And as soon as these two meet, we see that drug consumption, which is the red line over here, reaches zero. So then in this case, we would see that this first treatment of 100 time points was effective, like a comprehensive treatment of 100 time points was effective in reducing drug consumption. And yeah, in this case, it would then refer to addiction. What is also interesting is that after treatment stops, we do not see that drug consumption goes up again. That means that learning has occurred during the treatment that was sufficient for the person to then maintain the abstinence and avoiding relapse, which is one of the main issues of drug addiction as well. And that is really like, we can really see why or how that happened here, because we see strong learning. These are the values of the adaptive states. And we see that for many states that are related to craving strength, there's a sort of extinction happening because their values are going down. And for a lot of states that are related to drug impulse control, we see that a lot of the connections become stronger. So then we looked at the same thing to see whether that comprehensive treatment would just be as effective if it was shorter. And we did see that the first treatment did lower drug consumption a bit, but it wasn't sufficient. So that would also again represent what we see in reality, that shorter treatments are not as effective as longer ones. It goes up again, and then only after the second treatment, a person is able to reduce their drug consumption and then have learned enough to also remain abstinent over the longer time. I think I will skip this first scenario because it's against similar stuff, but for the last one, we have the less comprehensive treatment. So two of the states have no connection to the treatment. And we see that drug consumption does go down at the beginning, not as much as with the previous one, which was more comprehensive. But then it goes up again. It does go down after the second treatment, again, not as much as with the more comprehensive treatment, but then we see a bit of relapse. Nevertheless, enough learning occurred during the treatment, as we can see through like movement of these curves as well. But the person did learn enough to self-regulate themselves afterwards they do need a bit more time, but then finally still like achieve abstinence. So overall, we do see these patterns that we would observe in real life as well in our model, that longer treatments are more effective and also more comprehensive treatments. So that really try to address several aspects that could feed one's addiction to kind of, tackle it. So we need to tackle several aspects to then be able to successfully actually address that addiction. So I will just conclude with some final remarks and takeaway. So again, we think it's important to know that there was when it comes to addiction research, is really not much precise, quantitative, and especially consistent data, which made it difficult to really compare on a very precise level how did our different states would behave in this model. I could not say, for example, that, or there was no consistent data that would say that motivation is this strongly linked, or the effect sizes are this strong to when it to impulse control. Which would have really helped to kind of construct a more precise data model. But at the same time, modeling is when it comes to modeling, one really has to be careful to not leave out the how individual or how different also each case is. This is not only when it comes to different addictions, but also to individuals. Which then kind of really could also explain why we do not have this consistent data, because addiction varies so much and it's so individual across cases that we also want the model to be open to be able to model many of these different scenarios and individual cases as well. And something else to keep in mind is always when we work with models, that models are simplifications of super complex real world processes that can never fully capture what is going on in the actual world. But at the same time, we also believe that modeling is about that in a certain way. It's about simplifying a complex process to the degree that we can process it better, can understand it better, can look at it and come up with new ideas. And in that sense, we believe that we were successful in providing a model for addiction treatment that is valuable because it incorporates multiple factors. It really builds on adaptivity, so on the key role that learning plays in treating addiction. And it is also flexible, that can be adapted to different types of treatments, to different types of addictions, and even individual cases. So with that having been said, I come back to where we started off. And we hope to have provided more insight with this presentation to the model that we introduced in our paper, which is an adaptive network model for drug addiction treatment. And if there's any questions, we will of course be very happy to answer them.